think you can do either way. Probably we are anyway going to upload to YouTube, right?
Sure,
So
sure. Yeah, it's recording now. So,
okay. Yeah. Hello everyone. Welcome to another session. Skills session. Today's about the first chapter of designing data intensive applications. Last in the last session. Today we are going to discuss about chapter 2 for this book club, and the chapter 2 is uh, data models and query languages. So, uh, based on last week's experience, I'm sure like we will not be able to cover the complete chapter. So what we decided was like we'll cover the chapter we'll cover the relational model versus data model part of it, and if we have time, probably we can also cover the query languages for the data. So, there's another part in the chapter which is the graph-like data models. So we'll discuss the graph-like data models in probably in the next week. So before jumping on to the second chapter, just wanted to uh, go over the quick overview of like what we covered in chapter one. So in chapter one, author actually introduced us to the basic concepts when we are building the data intensive applications, and like how it is uh, becoming like more and more important for the applications to understand the different kinds of data handling we have and how it needs to be taken care. So the concepts that he introduced in the chapter one were like the reliability, like how the system has to behave even when there are faults and failures in the system, which could be like software failures, hardware failures, or human errors, and so how that needs to be handled and how important that is. And also introduced us to the scalability, that is the ability of the system to cope up with the increased loads. He defined the data, described what are loads, different kinds of loads. Also give an example of a Twitter, like how they handled different types of loads they have, how celebrity load is handled versus like the regular person's load, because um, how the home page has to be different when we are querying for all the tweets versus what should happen when you tweet and how that should reflect towards all the followers. So give a good example of Twitter and introduced us to those, and also describing what are the different performance metrics like response time versus latency and like percentiles, and the important concepts that are needed to measure the loads, um, and a bit on the maintainability and how the systems needs to be made easy for the operability, and how they should maintain simplicity and also accommodate evolvability of the system. So this get uh, built up the uh, basic concepts through the first chapter. So with that, we can move on to the second chapter of data models and query languages. So I'm going to get started on it, but if anyone wants to, uh, the idea is like go over the quick summary of the second chapter and then start discussing about each and every concept. So I'll get started, but feel free to jump in and add more, uh, add more to whatever I'm talking about, or discuss more on those things. Uh, there's nothing like right or wrong question, so please feel free to jump in anytime you like. So the way it started with is like how the databases are layered. So the way he started is like um, when we try to start building an application, we look at the real world, saying like people's, organizations, goods, actions, monies, and these are all the real world objects, right? And then those get converted into probably the object-oriented classes and objects, and those get that's the second layer of it, like the real world to the second layer, and then those gets converted into like, okay, so this will be represented as JSON objects or XML documents or tables or anything, which is like what the database is. And then again, uh, that data is again converted into like more of like memory bytes, and like more of like how the actual memory is maintained by the operating system and all. And then again, like more in depth, it goes into like the chips and like the pulses of light, magnetic fields and all. It's a very low level. So what he says is like, it's like data is handled in different layers. So, and how it needs to be handled for easy querying, accessing and all these things is what uh, how you represent it as the data model. So that's how we started with that. And so um, so in this chapter, I think we are going to compare mainly the relational model, the document model, and also, like I said, a few graph-based models. But for today's session, we'll stick on to the relational model versus the data model, and probably some query languages. Okay. So when trying to compare with the relational model versus data models, so
So
one of
before, uh, hi Naga, before we move to this part,
Mhm,
I was just thinking of something, and I was trying to create a mental model that what should we think about when we are discussing this chapter.
mhm,
So I was thinking that, so basically, like we solve lot of algorithm problems, right? And algorithm, we see a lot of those algorithm problems are real world problems.
mhm,
And now to solve that problem, we have to store some data in the memory. I'm talking about a simple algo question, right? So
right,
we have to store some data, and then we have to process the data.
mhm,
So during solving that problem, we decide what data structure we should use. Should we use array, linked list, and all those things, right?
right,
And the storage will depend on, like, we have to be optimum in terms of using storage space, and we have to be also optimum in how we use that data, how we query that data, right? And we have to think about that, and then we have to come up with a data model on how to store the data. So there also we are storing the data in RAM. RAM is also a storage. It's just a volatile memory that it will delete once we restart it, right? Here also, now we are discussing that we have to store the data permanently for an application.
mhm,
So based on the requirement, what our requirement is, how do we actually store the data, what kind of data model we should have in mind, so that first we can store the data efficiently, and second, based on that application's requirement, how it queries the data, what is the best way to store the data such that it's easier to write those queries and fetch the data.
yep, I completely agree on that. Yeah, that's a nice way of yeah, looking at it, right? Yeah, exactly. So we can start with very simple, like when we start writing our algorithms, like what do we how do we model the data so that it can be easily accessible for our application needs. But you're also talking about like how do we store it so that it can be easily accessible for our application needs. Yep.
Yes.
I like that approach. Yeah, that's true. That's true. I think that's what the data model is all about, right? So you define something so that it can be usable for your need. That could be an algorithm, or that could be an application, or that could be a web page, or anything. Yep. That's good. Is that Uday?
I'm so no, I'm Abhishek.
Yeah, hi. Yeah, Abhishek. Yeah, that was good. Cool. Thanks, Abhishek. So with that said, anybody have anything to add, or any other questions?
Yeah, just a quick thing about the way Abhishek explained. That was really nice. The only like a small caveat I would add there is, Abhishek, what you explained is very similar to like the idea of data structure, right? We are following a data structure and then it impacts the operations and underlying storage. I think when it comes to like, in general, there is another layer of data modeling that is there, which is called conceptual data modeling, which is what Naga was also capturing about lay out the entities. What is, when you're thinking about a full-fledged application, what all do you need to, represent? So that may be a little more broader, but definitely what you talked about is, that is where we'll go. But there is another layer. That's what I wanted to highlight.
Yeah. Okay.
Okay. Let's move on to this section in the chapter where the author tries to compare relational versus data model. So basically, to get started with, one of the very famous the databases that we have today and the models that we use are like the relational data models, relational databases, and SQL tool to query and look at the data. So most of the relational databases typically are used for the transactional kind of processing of data, like sales, banking transactions, airline reservations, something like that, and also like batch processings, like customer invoicing, payrolls reporting, and all is what he talked about. And these were like very famous. Uh, very famous and used in most of the systems so far. Now that like we're moving to NoSQL, but that still is like the major portion, majorly used actually, I would say. And then I think then recently, like there are a lot of NoSQL kind of databases that came in. He made a good reference to what NoSQL means, right? I think we have been using SQL, and like when I heard about NoSQL, I thought like, oh, this is, yes, it's not a SQL, so we are calling it as NoSQL. So I mean, like I believe like most of you understand what that is, right? It's not NoSQL, but it's actually not only SQL is what it is. So, uh, and uh, I mean, like of the people who are in the call, like, have you guys used mostly RDBMS or also NoSQL? Like, can we get a quick uh, check on like how many of you guys have got a chance to work on NoSQL? Uh, do you have
So
a lot?
this is
I
Ashok.
do.
I use MongoDB,
Mhm.
NoSQL, in one of the project.
Oh, the project MongoDB. Okay. Yeah, I think we are going to discuss about MongoDB. Uh, yeah, MongoDB in this. Yeah, not completely. I think briefly they talked about MongoDB here. Yep.
Okay.
This is Harish.
Hi,
I
where
used in hello.
Yep.
Yeah, this is Harish. I just used in couple of applications this RTVM.
Oh,
I was
that
using MySQL.
MySQL. Okay.
Yes.
Cool.
yeah, hi, this is Shobit and I've used Elasticsearch and Post.
Okay. Shobit, I think your voice is breaking, but yep. Thank you. Yeah, that's good. I mean, like, I'm trying to get a gauge of like, I still think like there are a lot of companies and a lot of applications still working on RDBMS, though the NoSQL is very famous, and so it's still being used. But there are some specific advantages to of NoSQL. So he tried to compare like the very specific advantages of like what NoSQL gives over the SQL databases. So in general, it has a greater scalability when compared with the relational databases. which is like usually very high write throughput is what NoSQL gives. And it's also like widespread because there are like very lot of free and open source softwares that are available. And uh, they also say, he talked about specialized query operations. I didn't really understand what he meant by specialized query operations. I'm assuming like getting the I thought like the specialized query operations would be like getting the full data at a time rather than using joins, which are very common in relational database. We can get into it more.
Naga, your first point, you said non-relational databases are more scalable. Why is that? Do we know why? What's
Uh,
the reason?
yeah, let's get into it actually. So it itself is like a specific topic, I believe, like why it is more scalable versus more
Yeah.
scalable when we compare with the relationals. Yeah. We'll get into it actually. That's a good question. Um, so some of the advantages, the other advantages are like uh, relational databases are like very schema oriented. So, and the NoSQL are like the schema less, which makes it more advantageous. Is uh, one of the advantages for the NoSQL databases he talked about. So, other than these, do you guys think of any other advantages of using NoSQL versus relational databases?
Hey Naga, there's one thing on the. Do you want to elaborate on the schema-less part? Because I think that is a common, sometimes a misconception among people. Like
People,
it's not really schema-less, right?
yes, and in one of the sections we are going to talk about next,
Okay.
talk
Okay.
Wallace, right? So he talked about like all these things. Like when he talked about advantages, he just listed out these advantages and he talked about those things again in the next sections.
Okay. So you plan to
Yeah,
take that later.
yeah.
Okay. Okay.
So he gave an example of how a resume is stored, and he talked about what what that means. I think scalability part, like someone asked, he did not cover in this chapter, but I think he covered in further chapters. But we can talk about it before we jump in to the next section. So these are the basic advantages he talked about. If you guys have anything else that you have seen, uh, you can just share it. Otherwise, we can move to the next sessions.
I think there was one point about impedance mismatch. So I haven't worked much on NoSQL, but I think one of the points covered was that uh, given for some applications, the difference between the application layer architecture or the code um, and the underlying data model with NoSQL, there can be relatively less, uh, what do you say? They might be more aligned compared to relational and application model. Uh,
Mm.
so, I mean, I personally haven't used it, but it was in general as a concept good to know.
So
Mhm.
yeah, that point was really good because like generally when we're writing code, most of the
Yeah,
time we use object-oriented concept.
right.
And in object-oriented concept, we have a class. So
Mhm.
that class has some native data types, and then we have some derived classes. Like an example is a job profile, which will have a name, age, and then it will have a sub object that my job history. So
Mhm.
this kind of representation is very easy to represent in a document DB because this data can be represented as a JSON, where this job history is another sub sub JSON, which can be exactly written to a document DB. But
Mhm.
if I'm creating a relational DB, I have to think about that mapping. That my first table is job profile. That job profile will have these data types. Then to represent the job history, I need to create another table. From this table to that table, I need to create joins. So this is that additional thinking which I have to do, which is very easy in
Yeah, yeah, it's not that natural in relational model.
yeah, yeah.
Yeah, I think that's the concept that we talked about last time. relation mismatch is what he talked about. So for the scalability part, I think it itself is a bigger concept of like why it is highly scalable versus when we compare with the relational database. So let's try to cover that in the next sections. So for now, we'll continue with the data model part here, whoever was asking about the scalability. Okay. So the object mismatch, whatever you guys were talking about, right? So exactly, like most of the programming languages that we use are like the object oriented programming languages. And when you look at relational database, if it is all tables and like if it is split across different tables, so the programmer has there should be a conversion between like how you represent the object and systems in an object oriented way and convert it into these tables and all this stuff, right? That's what like what Dippy was calling about impedance mismatch. So there is a mismatch between what we are representing in the application versus what it is represented in the database. So this is the impedance mismatch, one of the issues with the relational database that he talked about. And he talked about like there are some frameworks that are available, like object relation mapping framework, and also Hibernate. These are some of the frameworks that are available to handle that mismatch, but I don't think they have handled it to the full extent. I have not used any of these things, but he mentions that they haven't handled it to the full extent. So yeah. So with that said, again, he started with an example like I think Abhishek or someone was talking about like how do you store, like he took an example of you have a resume to store in the database. How do you store it in the databases, and what advantages you have of storing it in a relational database versus a NoSQL database? He compared these two things and explained the different concepts into it. So for example, like he took this example of resume, right? So if you have to store a resume in a relational database, right? So you'll have like different things in the resume, like uh, the username, first name, last name, the summary, uh, the industry you are working in, the different experiences, the recommendations you have for everything, all this profile that you want to store in the resume, right? So if you have to store it in a relational DB, so you'll be creating multiple tables to it, like um, the you'll have an industry table where you store like, oh, this is a software, uh, this is a software industry, this is like manufacturing, this is the finance sector, and all these things. And then you have uh, the regions, like, oh, this guy, to store like different regions people are working, like you have to store each and everything that is represented in the resume into different tables, right? Like there's a simple name table where you store the first name, last name, and the photo ID, and may not be the photo ID, but probably the link to where the photo is and all these things. So, but when you have to um, access this through the programming language, then what you have to do is like you have to join all these tables to just show a view of the profile, right? So that's kind of that's possible. It's not like it's not possible, it's possible. But there are like every time you have to do it, you have to do that part of like joining all this stuff. But when you get to like if you want to store it like in a NoSQL way, you don't have to do all of it. You just have like a user ID and then a full representation of the resume in a store in the document oriented databases. You just store it like a complete JSON or XML, and then you can show it up to the user as needed. So that's a very uh, good advantage to it. But then also then um, uh, then there are also some challenges to it, right? So there are also some challenges to it when you store it like that. Um, so the advantages he talks about here are like the schema flexibility, like whenever you have to change something in the uh, database. I think the example he gave is uh, dividing the sorry, I think I'm jumping ahead a bit here. uh, Sorry, I'm jumping ahead a bit here. Okay, okay, okay. So sorry, let's talk about the schema part a little later. So um, okay. So when storing the database, when storing it like a user to JSON model, what he talked about is like it's a kind of a um, one to many relationship, right? So it's like you have a user ID, and this user ID has many things to it, like the name, the location, the contact information, the summary, and all these things. So in those kind of scenarios, he says like there's a good way to use the NoSQL way, which is the document-based models, the user ID, and there's a representation of the complete thing in the blob. But when you are when you have to represent more than one to many relationship, so I mean, like, have you guys got the concept of like what this?
Yeah, so Naga, I just wanted to add to actually correct that a little bit.
Mhm,
So about one-to-many relationships, it's
mhm,
not so much about that one user has these multiple bits of information to be stored, but
mhm,
it's more about that, for example, one information piece, like let's say what are the job positions you have held, right? One
mhm.
person can have multiple job position. It's still talking about job position, but the data values can be multiple. So that is where the many part comes in. uh,
Right.
it's not so much about like if one user has, you know, like whatever, like the summary, first name, last name, all the different bits to be stored. That's not where the many part comes in. It's more about many values for a single attribute, so as to say.
Oh yeah, yeah.
So
That
one user has lived in different locations, right, address wise. So address is one piece of information, but it has multiple values, and that is where the many part is there.
Oh yeah, you're right. Sorry, my bad. It was not summary and all. The many
Yes,
comes
so,
where
so
you.
and I think in relational database, the problem is you have to make everything flat. So uh, like what we mentioned, that if a user has multiple addresses, then if we are creating a user table, then a column with addresses, it's hard to store those multiple addresses in a relational database. Either you need to create another table for addresses, right? Because you have to make everything flat.
Mhm.
And this is what he was saying. I think that this is good in document DB because this hierarchy where you have multiple levels, you
Mhm.
can define those hierarchy within that object, and you don't have to flatten it, right? So
That's true. That's true. But in general, knowing databases, I feel a little bit about this concept that uh, that is very accurate what you said, Abhishek. But in terms of, I won't go on to say that relational can't do it, because essentially what document DB did is it's like a denormalized version, right? Um, but yeah, you're coming back to your point about atomicity, right? You don't want to have multiple values. Sure.
no, yeah, I mean, no, I'm not saying that someone can do it or someone cannot do it. Every database has some way of doing it. It's just like what is easier to understand. So it's about easier to understand and performance and all that. But everything can do it. In fact, so I think what he has also mentioned is that now some SQL databases, they are trying to support this uh, this kind of
Sure.
model where you have a hierarchy where you can put in a JSON file where you can put on a JSON string inside that column. And it's not just any string, you can put indexing and all on that JSON string, so it will understand that JSON.
Sure, sure. Yeah, makes sense. I think what is also interesting is if we also, anyone can elaborate on that, about why we do that in relational model. Why do we split it across multiple relations if we go that route? What is the benefit that it gives us, right? I think in general, understanding the design of that is also interesting.
Yeah.
So, yeah.
I think the way why we want to split it across the advantages of having splitting it across different tables is like uh, it's like normalization. Right? You are actually normalizing it in such a way that you don't have to uh, store the values repeatedly.
Sure, sure, right. And
That,
that gives us the right benefit. Yeah. Inconsistencies can be avoided.
yeah, inconsistencies can be avoided and all. I think those are
Right.
the advantages of having the relational database.
Correct.
And like Abhishek was pointing out, I think he also covered points like in NoSQL we talked about saying that you could actually store everything as like as a blob
Yeah.
in the NoSQL, but SQL also relational databases are also supporting this concept of like storing it all like an XML or JSON. I think initial relational databases don't have this advantage of like querying through that blobs or like indexing through that blobs, but now they have also added that kind of a support there. So again, I mean, like I think he at the end of the chapter he got to a point where like it's not like one is better over the other. It's just like they will go together as needed for the application is where he was getting to. So yeah, so I think that's how he ended up. He ended the chapter, but uh, each has its own advantages and disadvantages. So okay, so let's get back to looking at the advantages. We're more talking about the advantages of the document-based one here. So one is the schema flexibility he's talked about. He gave a specific example of how this schema flexibility helped. We'll get to that example. He talked about one more concept called better locality. Uh, so have you guys heard of this term better locality? This is the first time I have heard in this book actually.
Yeah.
Yeah. So when he talks about better locality, he talks about like when you query the database, if you have all the data which is related to what you are querying together, the queries are faster in rather when compared to having the data split across multiple tables. That's what he talked about. He talked about briefly like the uh, disk seeks are also very fast uh, when you have this all together, but I was not sure if that is very true, given the underlying data stores are all SSDs, and we no more have to deal with the disk seeks and all. So I was not quite completely in alignment with that part, but that's my understanding about that.
So I'm not very sure, but I think what he was saying is that like if we have related content
Mhm.
together stored, then when we are looking for something, because the OS will pick up the data of that fixed page size, so there are higher chances that when we are reading something, we will also pick up the related data, and the reads will be faster. Whereas if something is in different tables, completely different tables, then you would have to first read on that first table, and then you would have to read on the second table. That's why it will take more time.
Yeah, and talk exactly. Yeah, and in talking in terms of storage, I think like it's like you said, Abhishek, it's about like when you're fetching blocks, right, from the disks. Then can you fetch the if the data is together, then you can fetch possibly let's say in one block versus you have to fetch like 3 blocks.
Mhm, mhm. Okay. So OS has its own advantages of like based on the locality of the data. Okay. Yep. Good. Good. So moving ahead, given we are already like 8:38. Okay. So so one-to-many relationships, right? Yeah. So like DP mentioned, it was more of a relation of like one user ID has relationship to like probably um, different. DP, did you mention like it?
Yeah, like different job profiles or different addresses, right? Multiple addresses user has stayed in.
Mhm. So I was looking at it as like when you say one-to-many relationship,
Yeah.
so this user has a relationship to this educational institution. Another user also have a relationship to that same educational institution. So that is when it's a
That
proper.
will that will become many to many. So many to many is like one to many from one direction, right? One user has multiple, let's say, institute 1 and 2. And
Mhm.
then that institute, like you said, is also mapping to multiple users, right? So from the other direction also it's one to many.
Oh yeah, yeah, yeah. Many users having relationship with.
Yeah, yeah.
Okay, okay, good, good. Okay, I think he also talked about like handling this many to many relationships and also many to one relationships.
Yeah,
Yeah, exactly. He talked about the example of like how educational institutions and locations are used to handle these different kinds of relationships into the database.
right.
Okay, so when we talk about this document databases, they also have the concept of the document references which are used, which is like similar to joins. Like in joins, we have foreign key. Even in the documents databases, we have this document references stored, which can help us like to reference to a different document, right? So, but they have their own disadvantages of like when querying the data, you have to make calls to multiple references to actually formulate the complete data. So that because of which there are some disadvantages of it, but the concept of uh, referencing to multiple documents within the document is also available in it. Um, that's one. I think. Uh, okay,
Naga.
so yep.
Yeah, so you can link between documents, but it still is gonna take time. So the generally used, as people have already mentioned, uh,
Mhm,
so when you use MongoDB as a document service, it shines when there is no relation between documents. I
mhm,
mean, if the data is all stored in one document,
mhm,
that is where it shines. But if you are having relationships between documents,
Yeah,
it is gonna take time. I mean, MongoDB supports some operator to get the related documents together, but that just reduces the latency between the client and the database. But data is gonna still gonna do still has to fetch the related documents together, and that is also where you are seeing the locality. So the whole document is stored together.
mhm.
Uh, but in RDBMS, you have to join multiple tables together to get the related data.
But when you have references, right? So the application has to go back and query each one of them. Right? It's not like it's still together, right?
No, no, no. If it is one document, it has to just take out a blob. So it has to read some 4 KB, 8 KB, some chunk of contiguous data together.
Mhm,
Uh, but if there are multiple tables, you have to read from multiple different disk locations.
mhm, mhm.
So even in the chapter ending, the references part, they show mention actually one point. So Oracle has a concept of co-located tables. So when there's a foreign key concept, you need to join tables based upon the foreign key and these all. But that actually you need to do from different disk locations to get the related data together. Uh, but Oracle has a concept of you can actually mention while creating the table saying that these are cluster tables. So maintain these tables in a combined in a uh, in a similar data location. So basically, if the foreign key data records for multiple tables are stored together into the disk. So that is where data locality gets, uh, it decreases the latency part.
Oh, when you say like all these tables are in a clustered tables.
Yeah.
So you are saying that, Oracle actually, when it write the data, so it write that particular record and the foreign, another table record together, so that read can
It tries
improve.
to maintain
Yeah,
all of
basically you can control the placement of your tables.
Yeah.
It's similar to like clustered index, right?
Yeah, sort of.
Okay.
Yeah.
Interesting. Okay.
So that's the data. Yeah, definitely that's there. The other thing I noticed there was about when you have one-to-many relationships. Like I don't know if Uday was speaking before this, but so in one-to-many you can just retrieve the whole document. So that's a benefit, and this whole data locality stuff. But the downside of these, NoSQL stuff is all like in figure 2.4 in the book. They show an example of many-to-many relationships, and in both relational and NoSQL, you have to do some sort of join, right? Like retrieving these two documents and merging those, like mapping those records. The challenge with NoSQL is that you have to handle all this logic at the application layer. Whereas in relational databases, the joins are taken care by database layer. So it also, I like to think about it in terms of pros and cons. So that is where I was thinking that
Yeah.
data locality is a benefit, but then there is also a downside.
Yeah, and I think the author talked about like there are query optimizations that are a lot of
Yeah,
optimizations that are built into the database.
yeah, they're very mature in relational.
So, yeah, and I don't understand this. So why is joins hard in NoSQL database? Why do
No,
they
no,
say
joins are not hard. It's about where are joins handled, right? In relational databases, the engine, the query optimizer handles joins for you. The moment you say, I want to select this data from table 1 and table 2, that's all you specify, and joins are handled inside your database engine code. But in NoSQL databases, what this is saying is when you have to do these joins, you have to write that logic in your application code that, okay, give me this document A, then give me this document B, and then, I want to have field 1 from document A and field 2 of document B joined on this condition. So the point is not about joins are not well handled in NoSQL. It's about when they are needed, then that handling is done at application layer, not at the database layer. Does that make sense? Or
Yeah, I think that makes sense. Yeah. So you build those optimizations once in the database engine, and that can be used by different applications versus like application handling all of those joins.
and it's cluttered also, right? If you have to write all this logic in application, yeah, it's
why if it's a general thing, why didn't NoSQL databases implemented this thing?
That's a good question, actually.
I think one of the reasons might be that, first of all, they are not designed. I mean, they can support this, right? It's not like they cannot support many to many, but they're idle. It comes back to the use case, right? uh, the way I understand NoSQL is they are very good for handling a certain use case where the data is in a certain, like maybe one-to-many relationship. If that's what your data reflects, then NoSQL shines, and that's where you should pick them. But uh, no data model can support everything, right? Like there are limitations of relational also. So I mean, that's how I look at it, that
Yeah,
nothing like is perfect.
exactly. I think if you have to do like multiple joins every time, then NoSQL is not the place you want to
Yeah, yeah,
be. So it's depends on the use case. It's not like they haven't implemented it there. I would think
yeah,
it like it has its advantages of where you don't have to do all this. You don't need to
right.
do all this joins every time. If you are joining every time, rather store it as a joint data, right? Why do the joins and store it in different tables?
Yeah,
I would look at it in that way.
yeah.
Okay. I think we are a bit out of time, but I just want to cover this schema flexibility of document DB versus a relational DB, right? So, are you guys able to see my screen?
Yeah.
Yeah. Okay. So, what do you mean by the schema flexibility here, right? So, if you take an example of the resume that we are talking about, we store the data as like the name, company description, and all these things. So he gave us a very simple example of like you have this data stored in relational database and in the document database, and you have the name stored as first name plus the second name in one single field in both of these databases. So if you have to make a change in the relational database, you have a table with a name field. And if you have to change the table to have the first name and second name, what are the changes needed in the relational database and what are the changes it is needed in the document database? So he talked about these two things. So if you have to make that change of splitting one field into two fields in a strictly schema oriented uh, relational database, what you have to do is you have to actually alter the table and create a alter the table and create a new row and fill it completely by dividing the first name and second name, right? So it's kind of a costly operation and it requires a downtime on the database to do that change. So that's with this strictly schema oriented thing, right? Because every time you write the data into the database, it is expected that the data needs to be in that particular field format. So if you have to change that, you have to make the change, and it's a very costly operation. In case of non-schema oriented NoSQL databases, what he suggested is like a very quick thing is like the application can quickly handle saying that whoever is reading or writing, he can just split it and then give it to the user as needed, or introduce like two new fields into the schema-less thing and just write into it, right? There's nothing like a table or something in the database which is defining that particular schema that the name has to be like this and you cannot have like two fields into it. So that's like a quick fix. There's no downtime in the database and there's nothing like refilling the data and all. So application can easily handle it. That's the advantage of having schema versus schemaless. And again, even in the case of schema-oriented databases, it can be handled in the application as well, but the data in the database all the old format. So that's a quick example he gave on like how having a strong schema in the relational databases versus non-relational databases have. So
Naga, let's wrap up. It's already
Yeah,
52.
yeah.
yep. So that's something that he talked about. So I believe like I think I jumped ahead and back and front today a bit. Uh, but let's see, like let's try to discuss these concepts in the Slack channel if you have more things, and
Yeah.
then try to cover the script languages and graph-like databases in the next session.
Yeah, sounds
And
good.
yeah, Dippy, could you please,